Hi everyone, it's Shamila again from Can Do Teach. Over the last few videos, we've been looking at a bunch of different techniques for factorizing quadratics. But you might have come across some quadratic equations that just don't want to be factorized no matter what you try. So that's actually okay. It's possible that either the quadratics can't be factorized because there aren't any solutions, or that they can be factorized, but the solutions are not whole numbers. So they're numbers that you never would have thought to try. Okay, so in this video, we're going to be looking at the completing the square method, which actually works with any quadratic equation that's thrown at you. So let's take an example of a monic quadratic, x squared plus 2x plus 5. So at first glance, this just looks like a normal quadratic. We might try to factorize it, but we'll quickly get frustrated because there aren't any numbers that multiply to give me 5 and add to give me 2. At least there aren't any whole numbers. So when I've tried and failed at factorizing, I actually move on to the completing the square method, which goes like this. So I start by looking at just the first two terms. And I take this constant term and I kind of push it to the side, literally. So I'll just write it over here. So it's still there, but I'm kind of ignoring it for the moment. And what I do is I look at these first two terms and I think, what number, what constant here would actually make this a perfect square? So if you remember from our perfect square factorization video, the perfect square form is the one that has a square number here. And this is actually the square of half of this term. So if I go half of this, I'll get 1. And if I square that, that gives me plus 1. So I can't just go about adding 1 wherever I like, so I have to subtract 1 as well. And that way I haven't changed anything. Alright? So that part is actually completing the square because I added in this constant term that makes that part a perfect square. Alright, that's why we call the method completing the square. And so in the next line, I take this part and I factorize it using the perfect square factorization. Okay, so this is the same as the red brackets here. And then the minus 1 plus 5 just becomes plus 4. So that's actually done. I can't factorize it any further than this because it's a plus in the middle here. So if we think back to our different forms video, this is actually now in the vertex form. So that's actually what we use the completing the square method for, is to change from the general form, which we had here, to the vertex form. Alright, so let's take another example. So x squared plus 10x minus 5. And this time, I actually want to solve this equation using this method. Alright? So again, I would look at this quadratic and think, can I come up with any factors here? Anything that multiplies to give negative 5 and adds to give 10? And I can't come up with anything. So I go into my completing the square. So again, I write the first two terms. And you can try and do this with me. And then I leave a space before the constant term. Okay? So make sure you write these in so you don't forget about them. And this time, so 10x there. And this time I have to think, what do I add here to complete the square? So this is 10. So half of 10 is 5. So this must be 25 or 5 squared. All right? So I go plus 25 minus 25. And so I've got a perfect square here. And I end up with x plus 5 squared minus 30. Alright? So that's now in the vertex form, but I'm not done yet because I wanted to solve this equation. Alright? So I can now use difference of two squares factorization. So while this isn't actually a square, I can turn it into a square by going square root and then squared. Okay? So now I have a difference of two squares. So to factorize that, I just go my two brackets equal 0. This goes in the beginning of each bracket. This goes at the end of each bracket. And I put a plus in one and a minus in one. So that's now completely factorized. And you can see that these are factors that you never would have come up with. So to solve, I just say, well, the first bracket would be 0 if x was equal to -5 minus root 30. And this one would be 0 if x equals -5 plus square root 30. Okay? We can look at our square root 30 and think whether it can be simplified at all. So root 30 is the same as 3 times 5 times 2. So since those are all primes, I actually can't simplify the start anymore. So I can just leave it as root 30. So we can say that x is equal to -5 plus or minus root 30. That's just a shorthand way of writing both solutions in one go. Alright, so I'll just go over one other way to solve this. So this is solving by doing difference of two squares factorization. But if I had this part of the equation, x plus 5 squared minus 30 equals 0, I can also solve that directly. So I can go x plus 5 squared, move the 30 over, that gives me equals 30, then square root. Now when I do a square root, I have to remember to put the plus minus, because both positive root 30 and negative root 30 will both square to give me 30. Alright, so that's really, really important. I'm going to circle it in red, it's so important. So the last step is just to subtract that 5. So minus 5 plus or minus square root 30. And that's exactly the same thing I got over here. Alright, so that's our completing the square factorization. I do need to show you one example with a non-monic quadratic. So far we've been doing it just with monic quadratics. So we'll go here. So let's try 2x squared plus 8x minus 3. Alright, so this time what I'm actually going to do is factorize just the front two terms. So I'm just going to take the 2 out. So whenever you have a non-monic quadratic that you want to do completing the square on, you have to make sure you first factorize the a out. Alright? So we take that out. So we've got 2 out there, x squared plus 4x. And I'm just going to factorize the 2 from those two terms. I don't want to overcomplicate it by factorizing out of the constant as well. So I'll just leave that there. And now I can do the completing the square on this part. So to complete the square here, I need to add half of this squared. So half of 4 is 2, and 2 squared is 4. So I need to add and subtract 4. And it's really important that I do both the addition and the subtraction inside the bracket. Okay? Otherwise, they may not actually cancel out. And then I've still got my minus 3 out here, equals 0. Okay, so now this part, just this part, not the whole inside the brackets, becomes the perfect square. So that's x plus 2 squared. I still have the minus 4 before that bracket closes, and the 3. Okay, so now I'll expand this set of brackets by going 2 perfect square minus 8 minus 3 equals 0. Notice that I multiplied this by 2, but I didn't multiply this by 2 because it was already outside the brackets. Okay, and so I just have to simplify. . And that's now in vertex form, so it's done. I can do either the difference of two squares, but actually in this case I wouldn't do that because that's not a square either, so I'm going to have thirds everywhere. So I would actually go ahead and do just the direct solving. So I'll just do that real quick. Move the 11 over, that gives me x plus 2 squared equals 11. Divide both sides by 2. Square root, so I've got x plus 2 plus equals plus or minus square root of 11 over 2. And finally x equals negative 2 plus or minus square root of 11 over 2. Alrighty, so that's completing the square on a more complicated kind of equation, so a non-monic quadratic. So in the very last example, I'm just going to show you how to deal with fractions. So all the examples I showed you so far had an even b, so I was actually able to divide that middle term by 2 and square it to get a nice perfect square. But if we look at this example, which actually looks very friendly to start off with, we'll see what happens when this is not even, so when the b is not even. Okay, so now we look at this and we say, all right, I need to complete the square because there's no way I can factorize this. So I go x squared plus x plus something, I don't know what, and then I'll minus the same thing, plus 1 equals 0. Okay, so this time, when there's nothing there, I know that means 1. So half of that is going to be a half, and the square of 1/2 is actually 1/4. So I need to add 1/4, and I also subtract 1/4. Okay? And now this part becomes my perfect square. X plus 1/2. So that's the square root of this and the square root of this squared. Minus 1/2 plus 1 is plus 3/4. So it'll be plus 3/4 equals 0. And we can go through and solve that in the same way we've done before. Okay, so that's about it for completing the square. We've seen examples where we have monic, non-monic, even b's, odd b's, all of the above. Okay, so for a challenge, you can actually try and apply completing the square to solve the general form of a quadratic. So we'll go ax squared plus bx plus c equals 0, and you want to solve that by completing the square. Okay, so that's actually going to be quite tricky because this is a non-monic. We also don't know what b is, so we're going to end up with a fraction when we divide that by 2. But if you work through it and work through all the algebra, it's actually a really good test of whether you understand all of the steps. So I recommend you try some other questions with completing the square first, and then try and attempt this challenge. Okay? So I will be posting a solution video in the, a solution to this challenge in the next video, but highly recommend that you see how far you can get by yourself first. Alright, so this is one of the topics that students probably have the most trouble with, so I'm really expecting some questions in the comments below. And if you need any extra one-to-one help, remember you can always find it at candoteach.com. So thanks for watching, and I'll see you next time. Bye!